Okay, we're ready.
All right, so we just answered the first two questions.
Okay.
Just the normal questions. So we'll need the following data files, maybe the probability output. Let's go ahead and start. The correlation coefficient is used to quantify the direction and strength of linear relationships.
Okay.
Because that can be positive or negative with weak, moderate, or strong.
Yeah, exactly.
So 3 is the third one down?
Yes.
Okay, question 4. If the correlation coefficient is negative when one variable increases, and the first one, the other variable tends to decrease. They are negative.
Well, they're not negative, just it goes down. But you're saying like a negative slope kind of deal.
I'm sorry, Jonathan?
Like they're not necessarily negative, but they just decrease. Because
Okay.
you can still have positive numbers. Like as one variable increases, the other one tends to decrease, kind of like what you're saying, but they don't have to be negative. It could be like 5, 4, 3, 2, which are all positive numbers.
Yeah.
So 4 is A.
Yes.
Okay, cool. All right, number 5. The effective outliers on the correlation coefficient is not significant. When I'm reading the information correctly, I would say the answer would be true.
Well, there is some examples where outliers are shown and they really have a big effect.
Okay, so it would be false.
Yeah. Yeah, Jonathan is showing us those.
Okay. So here's an outlier. And so it's a positive slope, so it should be positive, but you can see it's negative.
Because of the outlier, yeah.
Okay. Same deal goes here.
Okay.
And like you could have something that's not very, it should have no really any linear correlation, but this is saying that it would have a strong positive. So, yeah.
Cool.
So is not significant, that's false.
Okay.
See, so it's my turn?
Yes.
Yeah.
Okay, so we gotta go to Old Faithful. Put in the information. And here's your correlation coefficient. 0.901.
Yeah, 0.901. What is the direction and strength between weight and duration is positive and strong? That would be the third answer.
Oh, great. Maybe I have to refresh.
Yeah, I had some troubles with that.
So if it saves, like I saved it, if I just refresh, will it be okay?
Yeah, as long as you have saved your previous answers, that's fine. I took a screenshot of the graph just in case they don't show up correctly.
Now, one of them did. Great.
All right, so it's my turn.
Yeah, but you need to see the pictures and they are not loading correctly.
Are they loading on yours, Jason?
They loaded on mine, but they're like, yeah, they loaded, but they're like all just a lot of stuff bunched together. So
Okay, I can share my screen with you. I have a screenshot of them.
All right. That's weird.
Yeah, it took several attempts for me.
All right, so I'll stop sharing mine so I could see yours, and then we could share mine again.
Okay, and actually it's not that hard.
Yeah,
Can you see it?
yeah, I can see it.
Maybe.
That's a smart idea.
There are 6.
Yeah.
So actually, the first and the one and number 4, I would say are the easiest ones.
So we have to match a correlation coefficient with the graph.
Yeah.
yeah,
All right, so we're looking at the first one. And Jason, you said it's your turn?
yeah. Oh boy. Seems like I always get the fun ones.
Yeah. If it is closer to 1 or if it's 1 is perfectly is a line, like in this case,
Right.
and going up in both axes. So you can see the second one is not that perfect, but it is really close to be almost perfect.
I took a picture just so you can see what shows.
And if one goes up, the other one goes up too. So
I'm saying like
it is a positive relation.
so it's from really
And D and E are similar.
almost the top of the sunflower. So that's it. Right here. So that's at like 3 feet up is all it shows. So
The first case, that is that one that you
my idea was
that you're looking for, is the example of one being perfectly positive or something like that.
Right.
not have to worry about the shells.
Yeah, so I would say R equals 1 would be A then.
But I like the idea of other people's art too.
So you say the first one is what number? What number?
I need it to be in a way where it
I said the first one, or so the letter A would be, if I'm correct, R equals 1.
but that wall needs to be
Yeah, that's correct. Yeah. It is a little bit weird that they have letters here, but we are just using numbers.
Right.
Yeah.
So 1 is equals 1. And the second one, negative 0.95, would be number 5. That is right here. It is negative, but it is not perfectly in a line. So that would be number 5.
So number 5 is which one?
The second value for R is number 5. Minus 0.95, negative 0.95.
That's the last one, right?
I'm sorry?
5 for me is the very last one. The negative 0.95.
It's the second to the last.
My second to the last is positive 0.95.
Okay.
I don't know. Here, I'll share mine.
Really? Do you have different graphs?
Oh no, I'm sorry. Maybe I'm looking at.
The
Um,
answers.
I'm looking at these right here.
Oh, yeah.
I don't know which ones you're looking at.
Oh, that's weird.
Is that what
Okay.
you're talking about, even on your quiz?
No, I in my quiz that was the second one.
Yeah, so these are the ones I got from your picture.
Okay. Yeah, 6,
So it's like that half.
3,
Yeah,
1.
one of
Yeah. Jason, what order do you have? I mean, for R.
Like, are yours
What is it?
like mine, or yours like Rafa's?
Yeah, mine's actually kind of a little bit switched. I actually have for where we put in the information, I have R equals 0 is like the first one, and then it goes R equals negative 6, 0.6 is the last answer.
What is the first one? R equals what?
0.
Oh,
That's well, basically the only one I have.
well,
So they're all in different orders.
Yeah.
That's
Yeah.
interesting.
you need to match the numbers that Jason is showing. 0 would be the third, the number 3. Yeah, because my first one is equals 1.
Okay. All right. All right. I got all that information. Cool.
Cool.
One's actually made by prop socket.
Whose turn is it?
I don't know.
I think it's yours.
Mine?
Yeah.
All right. Input the correlation coefficient. 0.728.
Yep. And the last one, where is the direction and strength between score and confidence? It is again positive and strong.
So if you don't get time, it's going to take longer. Kind of 2 day shipping, but holiday school. Today, and then Thursday.
So it seems like the pop socket ran. Those are like the actual brain, not the or
Okay.
All right.
So, could you, I don't know, did you at least follow the stocks thing with the covariance, Rafa?
Have I what? Follow?
Did you follow that stocks example, the covariance?
Yes, for the lesson, you say?
Yeah, towards the end, it was talking about covariance, and you want to pick like two negative ones.
Let me open the file.
Do you understand why you need to have two negative covariance?
And for the homework, we have very large numbers for that value, like 1 million or something.
$50.
Well, the numbers, right? Like that was calculating and everything, calculating the numbers. I have a feeling that they're gonna like have some kind of like application problem. And there could be some pretty huge covariance numbers.
Yeah.
Holy cow.
Ooh, no, you're like
Okay.
you are
Let's go to an elephant.
Yeah, but they don't explain much about the meaning of the covariance, right?
the sushi.
They talk
I mean-
about it.
Pop socket framework.
No, because it said pop socket, like pop socket.
So
Like they-
I mean, what? Yeah, what does the 11 means in this case? And as I was saying in the examples of homework or assignment,
Yeah.
we got really big numbers for that
Yeah.
estimate.
Oh, in between.
And I don't know what does it mean if it is a big number, a large number.
But so like I guess the thing that stuck out to me the most from that reading, here I'll share my screen again. Okay, so is this right here. So if an investor wants to purchase two stocks and they want to reduce the risk, they can choose two stocks with a negative covariance. Right. I mean, only thing I can think of are two negatives when you multiply them equal positive, but why would you want that?
Right.
I don't know. And then it kind of explains this, but I can't make the connection. It's if the return of one stock decreases, the return of the other stock would tend to increase. Is it like the same kind of thing? A negative covariance means this?
Oh, that's weird. So you can get a pop socket, like a regular one, and then you get a vinyl skin wrap.
Is correlation the same thing as covariance then? Oh, I know it's not the same thing.
One doesn't delete
but I don't know. I'll have to research it a little bit more.
I mean, ultimately, probably you're still going to.
Well, if you have three factors to multiply, and if the first one is negative, that would mean that they have a negative correlation. Like, let's say, I don't know, Apple and the New York Times stock. If they have a negative correlation, R would be negative, and
Yeah.
then the covariance will be negative at the end.
And standard deviations are always positive.
Yeah.
Okay. So two negative, not that two negatives will affect each other, so that each negative has negative correlation. Okay, that makes sense.
Yeah, just one
Yeah.
value.
Yeah, that makes sense.
And maybe the bigger the number, the greater the, I'm not sure, the greater the correlation. The larger the number, the greater. I don't know.
I think there's the larger numbers. I mean, standard deviations, like the spread of the data, might have something to do with that big number because the correlation coefficient is always between -1 and 1, so those aren't big numbers at all. So I think it's just the spread of the data.
Yeah.
With the combination, because if the correlation is 0.5, whatever the product of the two standard deviations is going to be split in half, you know?
Yeah.
Or if it's 0, then it zeroes out.
Yeah, there's a top clip and then there's a top side.
Yeah, maybe we will learn what if it does mean something. If the covariance is bigger, larger. Yeah, that was my only question because I got some bigger, some really large variances.
Yeah.
Okay. Should I start the broadcast?
Yeah.
I could do that.